Let's go to equal 1575. Count all possible routes. It gives us integer locations, and every integer in this location represents the position of city I. And we in giving a start and finish and field represent the start city and the city and the initial amount of field you have. At each step, if you are at a city I, you can pick up any city J, um, and which has J doesn't equal to I, and J should of course should be in this location's index, right? And move to J, and you move from I to J, you are using the amount of fields that is a distance, the location I minus location J's absolute value. So there is some limit that the field cannot be negative at any point of time. We can be equal to zero, but it cannot be negative. And you are allowed to visit the city more than once. So return the count of all possible routes from start to finish. And also, even those kind of finish, you can still revisit, right? So, let's look at this kind of location has is 100, and those kind of values for location is very big, right? And also, um, field is 200. So we can think about for this location N and this field, right? Even we have the power, any of this to be, it must be some kind of location. For example, this is N and a field, some kind of multiplications, right? Even there is some power time complexity should still be fine, right? Um, Here, the things that we can think about the state for each location, how many fields we have, right? So we consider those kind of locations and fields as the state. So there are two multiple two 20,000 different states, right? So if for each state, um we already have how many possible way to finish go to finish those kind of possible routes, right, from this state to finish. Then uh, we are um we are going to go some kind of iterations to the initial state. The initial state will be the start and a field, right? So, so here are the things that we can think about the DFS, right? So, but DFS it will have a lot of uh, we'll find out there is many states which we already been calculated if we use a DFS way, right? So, we should use some kind of memo to store for those kind of states and um those kind of states that is at a location and how many fields we have, right? So if we store those kind of states, right, we can use the DFS plus memo to do this kind of questions, right? So it is actually dynamical programming, right? For each state, we need to, but the thing is that for the state, the location, it's harder to iterate from left or right, right? So the convenient way it is we use the DFS plus memo to write dynamic programming function style, right? So here is we'll see the time complexity will be at least n multiplied by f, right? The fields and also because the field will always decreasing, right? And for each state, we may need to calculate all of the other locations we have, right? So will be at least n squared f, right? So we can think about we sort these locations first in some kind of order that if we doesn't sort that we are not change the time complexity, but since if we sort that is for each current location, right, we just need to go left and right, find if it the cost already more than what we have the fields so far, then we can terminate. So we don't need to go through every locations, right? So we can do sort the locations first, and so that we can trim, right? We don't need to go through all of the states. It will not change the time complexity, but since that it will just in fact be more efficient, right? So let's write the code for this actually. Because the it will be very big. We can have a mod, a private static int mod equals 1. And what we need is here it says that all of the locations are distinct, and this start and end is an index in the original location, right? So, what we can do is we can sort this. Uh, Here the locations normally we need to have copies that it will not change the input, right? But for this code, we can just sort just in our real work, we may need to have a deep copy of this. Let's do this. Let me think. So we'll say int n equals locations data length, and we need a start location equals locations start, and because they are uh, distinct, right? So we can find the value after sort. We just we can get the new index, right? And the location equals finish location equals locations finish. So we're going to have arrays sort locations, right? And then what we do is that we need let's have a new index called start index. That is the index in the sorted location equals originally the index is start and the finish, right? And start index let's set as -1 and the finish index equals -1. Okay. So what we do is that for int I equals 0, I smaller than n, I plus, right? So we'll say if locations I equals start location. Then let's say start index. That is in the sorted array, the index, right? And we'll write if locations I equals finish location. Then we'll have finish index. Say finish index equals I, right? So here, we can have a memo that is for, we can have two dimension, right? So that it will be its state. So the first dimension will be its locations, right? Locations, we know we can use those kind of index. So we put use a new index in the new array, right? In the sorted array. So we are going to have int n. And the second one will be how many fields, right? So initially we have field, right? So we need to have, and this field is going to decrease. So we're going to have field plus one as second 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 dimension, right? And we can initial this one as -1, right? So for our DFS, we're going to return how many different possible routes to this state, right? So we're going to have return DFS. So for this DFS, we're going to have locations and our state, right? So our state will have the index, right? This is start index and also our field and our end index, right? So memo, let's put end index here because this will be some kind of value does not change, right? And this start index and field, that is our current state. And memo will store all of the states, right? So let's write the DFS in the end index. And this is a current state, that is current index and current field, right? And also our memo. So we'll say if current field is smaller than 0, right? Of course, there it's impossible have any roots. So we are going to return 0. And if memo current current index and current field doesn't equal to -1, right? Then we just return memo current index and the current field, right? And we need a result, long result. So the thing is that if current index equals end index, right? Then we have one way we already reach this kind of destination. So we'll have one, right? Add one. Otherwise, it will not add to the result, so it will be 0. Then what we do is that we are going to for we from current index, because it's already sorted, right? So we can terminate early. So what we do is that here the thing that if we don't sort, right? We don't sort, we need to iterate all of the index. It's not optimized, but the time complexity will be the same. But this one, we just need to iterate to its left and iterate to its right, right? So current index, because it's already sorted, and I greater equal to 0, I minus minus, then we are going to have cost equals locations. So we can also ignore the mass absolute value because we know it's already sorted. So we use the current index minus locations R, right? So we'll say if cost is greater than current field, right? We need to break. Otherwise, we're going to have result equals result to the plus DFS locations I should be n index in the I in the field will be current field minus cost, right? And memo. And of course we should mod by mod, right? So for those kind of new location which is on its right, I equals current index plus one. I smaller than locations dot length. I plus plus, right? So we'll say we're going to have int cost equals locations I minus locations current index, right? So we'll say if also cost greater than current field, we should break. Otherwise, we're going to have result equals result plus DFS locations and the index. And I should be current field minus cost and memo and mod by mod. So in the end, we need to return this result. And before we return this result, we can save this to memo, right? So memo current index and current field equals convert this to int result in return result int result, right? Let's say this is a F index. Let's say finish index. Okay. So let's look at the time and the space complexity. You'll see there are n multiplied by f states, right? And for each state, we're going to iterate all of these locations. That is an ON operation for each state. So the total time complexity will be ON squared f, right? And the space, that is n multiplied by f for each state, right? Um, let's write a Python code for this. And Python, the advantage is that we can use uh, at cache annotations, right? So code will be simpler. And so we are going to have let's create a new array for these locations because in practical, it's better we don't change the original array, right? So N L array equals this will be the length of locations, and this will be sorted locations. Okay. Then we're going to have we need a SID and NID, right? SID finish ID, set this one as -1, -1. Okay. So for I in range, and we're going to have if L array I, because the location are distinct value, right? So locations start. Then we're going to have SID equals I. And we'll write if L array I equals locations finish, we're going to have F FID equals I, right? So when we write a DFS, right, we can have our use this one cache, right? DF DFS. So we are going to pass in current ID. This is int, right? And current field. This will be int, and this will return int. So we don't need the map current, and also because we don't need to pass in the ID, right? If we put this one as an inner function, so and also this array, right? We don't need to have that. If current field is smaller than 0, we just return 0, right? And we'll have result equals 1 if current ID equals and a finish ID, right? Else that is 0. Then we're going to look at its left in range from current ID -1 to -1. Use a -1 step, right? So let's say cost equals L array current ID minus L array R. So if cost is greater than current field, we're going to break. And then we'll have result equals result plus DFS I current field minus cost. We should mod, right? Mod self dot mod. Also for the right, I in range from CID +1 to n, we can have cost equals L array I minus L array CID. So if cost is greater than current field, we're going to break. So we'll also have result equals result plus DFS, that is ICF minus cost should be self dot mod. So we need to we use this cache function, right? We just need to return. We use these cache annotations, right? We don't need to write those kind of code to save it, right? Return result. So in our main function, we just return DFS current start ID and view, right? So this is the code.